In this session, I want to introduce you to the components we need to build astable, monostable, and bistable circuits. So stay with me. In this session, I want to introduce the components we need, and I have a request from you. At the end of the video, please write in the comments which circuit you think we should start with if we want to build these circuits. Now here, I'm going to show you an image of a sample astable circuit, and we want to introduce its components. As you can see in this image, this is the circuit schematic that we want to build, and we need a 4.7 kilo-ohm resistor for it, which you can also see in this picture. We also need a battery and a power supply, and as we mentioned, the 555 IC works between 5 to 15 volts. Here, I brought a 9-volt battery, but if you're using a power supply, that's much better. But in the astable circuit, which you can also see here in the schematic, we need a 5-volt battery. We also need a 10 microfarad capacitor, a 10 kilo-ohm resistor, and an LED, and we're going to assemble it according to this. So you can get the components I mentioned according to this schematic. And for each one, for example, if you need a 10 kilo-ohm resistor for this circuit, it's good to have two. Preferably, have one extra of each component that's introduced, so if one is faulty, you can use the other. A 270 ohm resistor is also needed according to this circuit, and of course, jumper wires are an inseparable part of working with a breadboard, and you'll also need a 555 IC. So these are the components we need for the astable circuit. Take a look at this circuit. If you can build it yourself, that's great. If not, you can follow along with me, and we'll put it together in the next sessions. This is an example of an astable circuit. Actually, the first oscillator circuit we built in the very first session was also an astable circuit, which was the simplest version. This one is another example. All right, for the monostable, I want to show you two circuits here, and we're going to build both of them. The components we need for this first circuit, notice that the circuit diagram here is different from the one we had for the astable circuit. I wanted to bring in several different types here so we can see how we can build our circuit according to all of them. For this circuit, you can see that we still need a 5-volt input voltage, or power supply, two 10 kilo-ohm resistors, a 470 ohm resistor, and a 220 microfarad electrolytic capacitor. These are the components I need. And of course, I also need a push button, which you can get in this size or another size, or really any switch that can turn on and off. Here, I'm using a push button because it fits better on this breadboard. That's for one circuit. The other circuit that we want to build for the monostable mode and demonstrate is this one. If you look closely here, I have a push button and a 10 nanofarad capacitor, but you could also use, for example, a 100 microfarad capacitor here. If you pay attention, in this circuit we have two resistors, which are R1 and R2, and one capacitor, which is labeled C, and we haven't specified its value. If you remember, in the monostable mode, we said that by changing the value of this resistor and capacitor, we can set the amount of time it takes for our capacitor to charge. So for this situation, you can use several types of resistors. For example, you could use a 10 kilo-ohm resistor, and for your capacitor, you could use a 100 microfarad capacitor, which could be a ceramic one, and use that. Or it could be another resistor with a different value. That really depends on you and whatever resistor you have on hand. And if, for example, you only have a 10 kilo-ohm or a 1000 ohm resistor, it doesn't matter. You can use it for this purpose, and let's change these values together and see how the amount of time it takes for the capacitor to charge changes. So here we have two circuits for the monostable mode that we want to build together, and for the astable or bistable mode, this is the circuit we want to assemble here. For the bistable mode, according to the schematic we discussed in the previous session, you can see here that we need two push buttons. So here I've brought two push buttons are needed, and we also need two resistors. For example, here I've brought two 22 kilo-ohm resistors, but you can use the same value or any other values you have available. What matters is the circuit's operation. The values I've used here are just a standard example that we can use, and in the next session, we'll actually swap them out and see what kind of output we get. Here we have a 10 nanofarad capacitor, and as you can see in this circuit, just like in the circuit for the monostable mode second state, we've specified the output, which is connected to pin 3. I'm going to place an LED at this output, and of course there also needs to be a resistor next to the LED. For this setup, for example, you can use a 390 ohm resistor, or a 470 ohm resistor, or even a 220 ohm resistor. It doesn't really make a difference. So these are the components we need to arrange for these configurations. The reason I first introduced this circuit and the components needed is so that you can go and get them as well. If you already have them, even better. You can set up this circuit right now and see how your output looks. You might have some questions, and if so, you can ask me your questions right below this video. Right now, you can get these components. My question for you is, which one of these circuits should we start with, so that in the next session we can build it and I can explain its details to you again. For example, I can tell you what process is happening when it's working in bistable mode. I'd appreciate it if you could write under this video which mode you'd like me to start with first: astable, monostable, or bistable. I'll start with whichever one gets the most requests. Then I'll make a separate video for the one that comes in second and another for the third. We'll go through each mode together, and after we've covered all three, we'll move on to building more practical circuits. I'd appreciate it if you could leave your opinion under this video, and in the next 2 or 3 days, I'll review the feedback and start building the circuit you're interested in. Thank you for staying with me up to this point. Don't forget to comment, don't forget to like. If you haven't subscribed to this channel yet, I'd appreciate it if you did. Also, hit that little bell next to it so you get notified whenever a new video comes out, and you'll be the first to see it. Thank you for staying with me up to this point. Until the next video, goodbye.